We've been talking about the discontinuities. We've kind of learned how to pick them out from an equation, situations where they might happen. Tell me what we would do on this one to find the discontinuities. Mm-hmm. So that would factor into x minus 2, x plus 1. What happens there?
Wait, would it be x
Oh,
minus
x minus 1. Yes, thank you. All right, now what happens? Okay, so when is this graph discontinuous? Tell me the type. At x equals 1, what type is that?
That's the
Infinite, because we will have a vertical asymptote there. What about at x equals 2? Removable, that's like an open circle. Those can be fixed. You know, if I wanted to make this continuous, the point that I would need when my x is 2, what would my y have to be to fill that in? Do you guys remember finding our holes last year? 2 is where it canceled. To find the y value of the hole, we always plug 2 into that final piece. If I put a 2 in there, I would get out 1. So if you added the 0.21 to this graph, if you turn it into a piecewise function and the point was 2, 1, that would fill in that hole and it wouldn't be an issue anymore. So removable can be fixed just by filling in 1 point on the graph. Look at this one. Anytime we have absolute value functions, what do we do? We break it into pieces. So if I were to rewrite this with pieces, we have to consider the case when x is less than 1 and the case when x is greater than 1 to really get a picture of this. If my x is smaller than 1, what will the absolute value turn into? Well, let me ask it this way. If x is less than 1, what kind of number are we getting inside the absolute value? A negative. And the absolute value would do the opposite of it. What happens then? Well, if I look at it this way, what could happen? We can reduce one of these x minus 1. So it turns into negative 1 over x minus 1 squared. If x was bigger than 1, then you're getting a positive inside the absolute value. So the absolute value doesn't do anything to it. So when you reduce, you just get 1 over x minus 1 squared. All right, where is this discontinuous? You don't have to worry about that, you just have to give me the x value. So it's discontinuous when x is 1. If I want to think about the type, we have to think about these a little bit. We know 1's on the denominator, so that means it's what? Anytime it's on the bottom, it's a vertical asymptote. If it's a vertical asymptote, that means it's an infinite. Now, if once I did my piecewise it was no longer on the bottom, then it probably would have been a jump discontinuity. So we had to think about, is that x minus 1 going to cancel off the bottom or not? If it's still on the bottom, we have the asymptote, so it's infinite. If it's not, then we're just physically jumping from one section of the piecewise to another, so that would be a jump. All right. Let me ask this question. I want to find a value of a so that this function would be continuous. Let's see just a bit. If it's continuous, what's true about these pieces?
They like match up.
They match up. Okay, where is the breaking point? Where's the point where I would be worried about them not being continuous? When x is 1, because that's where I break from one piece to the next. So let's plug a 1 into x, or 1 in for x. So the first one, give me 1 squared minus 2. The second one will give me a times 1 times 4. If it's continuous, then what has to be true about those values? They have to match up and be the same. I get -1 equals a minus 4. If I add over my 4, a has to be 3 in order for this to be continuous. So continuous on a piecewise means your pieces need to line up. So we had to look at what x value they changed pieces at, plug that in, and set them equal. Are there any questions about continuity? The last thing we need to talk about today is something that we have looked at previously, and it has to do with continuity. It's the intermediate value theorem. So we talked about it last year when we were looking at zeros of functions, and we said, okay, if I plug in one x value and it gives me a negative answer, and a different x value gives me a positive answer, I know that somewhere to get from a negative to a positive, I have to hit 0. But the key to that is it has to be continuous. Okay, if this one's negative and that one's positive, intermediate value theorem is supposed to help us find zeros. It's supposed to tell us that somewhere in between we hit the x-axis. But that wouldn't be true if the function weren't continuous. You know, if you think about a non-continuous function, I could have something like that, and it never hits 0 in between. So intermediate value theorem says if the function is continuous, one x value gives you a negative answer, one x value gives a positive answer, then somewhere in between you cross 0. So let's look at a couple scenarios. A lot of times on these, I will give you a specific interval. I'll say show that there's a 0 between x equals 3 and x equals 4, which makes it a little bit easier. Here I didn't tell you a specific interval. I'm just saying show me that somewhere there would have to be one. So first statement we have to make. This is a polynomial. Polynomials are always continuous. So we need to state that. So I'm going to say it's continuous because it's a polynomial. If you don't tell me that it's continuous, then you can't prove anything. Now we just need two different x values. Let's just pick one. If I put in 0, what do we get out? -2. So that gives me a negative answer. All right, I need an x value I can put in that gives me a positive answer. If I put in 1, still getting negative. What about when x is 2? So if I put in 2, 8 times 4 is 32, minus 24, plus 6, minus 2. We get 12. So if you think about what that means, 0, -2 is on the graph, 2, 12. And I know my function's continuous, so what has to happen between 0 and 2? So the sign changed. So some x value between 0 and 2 So in the intermediate value theorem, what I'm looking for, you have to tell me it's continuous. You have to plug in two x's, get a positive and a negative, and then tell me what that means. So since the y's are different signs, somewhere in between those x's it hits 0. Last one. Okay, assume f of 1 equals -5. So when x is 1, y is -5. F of 3 is equal to +5. Does there have to be an x between 1 and 3 that makes my function equal 0? You're shaking your head no. Why not?
Because it's not a continuous.
Yes. Did I tell you it was continuous? No. If it's continuous, then certainly there would be a place between that would make it equal 0. But since I didn't tell you it was continuous, we can't assume that. Any questions for me?